on your radicals. When you square a radical in any equation, if it was a negative and you're forcing this to become positive, you need to check to make sure that it works. Chances are it's not going to work. And this happens with anything. It'll happen regardless, without it being a trig equation. So, isolate your radical. I think we did this one in class together, right? I think we did this one in class together. Isolate your radical, square both sides. This pops out of the radical, okay? And solve. You've got cosine squared on one side, cosine squared on the other side. Get your cosine squares to one side. Isolate your square again, divide by 4, and then take the square root. You could even have taken the square root here. Oh, sorry. You could have taken the square root here. And then if you wanted to, divide by 2. Don't forget, when you take the square root, you're going to get a plus or minus. Plus or minus means you're going to have all 4 quadrants. So lay out the first quadrant. I have a 30-degree angle. So I know all my solutions from 0 to 2 pi, pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. You're going to have to check these. It's the ones that will become negative that won't work. So cosine is positive in 1 and 4. Cosine is negative in 2 and 3. That's why these two didn't work. Since this is an equation, put your mode in radians, and just put the whole thing in. Cosine, just take 5 pi over 6 minus the square root of 3 minus 3 times the cosine of 5 pi over 6 squared. And when you hit enter, if it's not 0, it didn't work. And then try the other negative. It's not going to work. The 2 negatives won't work. So you must say reject on those negatives. Okay? For some odd reason, my pen is writing really, really thick. Yes, I checked it. I need to change my pen.
Wait, can you go for 1 second?
Yes. I'm just trying to see how I change my pen.
Oh.
There it is. See if that helps.
So how did you get those angles after you did
After we get these angles, when we came down to here,
we went down to the cosine x equals plus or minus 3/4.
but 3/2, because we took the square root of 4. So you're going to get to this, and you're going to separate this. Radical 3, that's a little better, over radical 4. So you're left with radical 3 over 2. And because it's plus or minus, it's all 4 quadrants. And cosine is x over r. So x over r, we know this is the 1. We know that's a 30-degree angle. And 30 goes into 186 times. So this is my 6 pi over 6, and this is my 12 pi over 6. And the 2 that won't work are the 2 that are negative.
And it goes in all 4 quadrants? Like there's an angle in all 4?
All 4. Because where is cosine positive in 1 and 4, where is it negative in 2 and 3? So it takes all the quadrants. It uses all the quadrants. Okay. Seriously, I don't know what's happening here today. Okay, here's another one. Again, isolate your radical, put it to one side, square both sides, bring it out. It's the same situation as your cosines were. Doesn't it look the same? You got tangent squares on both sides. So get your tangent square to one side, divide. It looks the same exact as the one before this, except instead of cosine, It's tangent. Take the square root. When you reach this point right here, make sure you separate your radical. Otherwise, if you left 1 over 3 underneath your radical, it's not going to make any sense to you as a special triangle. Separate your radical. And again, when you made this guy become positive, it may not check. So when you check your answers, tangent is positive in 1 and 3. In 2 and 4, it's negative. And if we notice it, it's our angles in 2 and 4 that aren't going to work. It's your angles that have a negative tangent. That won't work. And again, put it back in your calculator. Put your mode in radians. Tangent of 5 pi over 6 minus 1 minus 2 times the tangent of 5 pi over 6. When you have a tangent squared, you just put this in first, close your parentheses, and then square it. It actually takes the tangent of that angle and squares it. If you put it inside this parenthesis, it will square your angle. And that's not going to come out to be 0. If it doesn't work. So again, that was in all 4 quadrants. Be careful of this guy, that you separate this. And square root of 1 is 1. So tangent is y over x. And I just asked you between 0 and 2 pi. Questions? Works the same way as the last one you did. Alright, this guy, I rewrote it over here. This is your half angle. Treat it as if it just says x right now. Factor it as it's a regular angle. And if you have trouble with it, it looks like this. There's no square on this guy. It looks like this. This is going to factor to x plus 1 times x plus 1. So it's going to factor to your cotangent. Right now, leave it as an x right now. And solve for that. So solve as if this is a regular x. So where is cotangent negative 1? Same place tangent is negative 1. And 2 and 4. 45-degree angle. So this becomes my 3 pi over 4. Now this wanted all solutions first. So if I hit this one, 180 degrees away, I hit the other one. Remember, I'm stopping at the terminal side. So I just say 3 pi over 4 plus n pi. Now I deal with my 1/2. 1/2 says, get that fraction out of there. Multiply every term by 2. When you multiply 3 pi over 4 times 2, it becomes 6 pi over 4, or reduces to 3 pi over 2. Then don't forget to multiply this guy. And it makes sense. We have half the amount of angles. If I had 2 angles in 2 pi, and I have half the amount of angles, how many will I have? 1. If my angle right here is 135, and I'm going to stretch this and technically double that angle instead of divide it, I'm doubling it, it will be 270. That's where your 3 pi over 2 is. So it does make sense. And then in 4 pi, I'm only going to have 1 more. So you have a choice. You could set this up and add the 4 to the top, or you can just count. If this is 3 pi over 2, you went by 1 pi over 2. 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2. There's your 2 angles. If you want to just go through the pattern, it's only just a small one. It's doable. Awfully quiet. We all have this on our paper. Owen?
Tell me when you did the cotangent.
cotangent.
1/2 x squared. Yeah, then.
This one right here. Well, remember, we're treating this as if it says a regular angle right now. So we say, where is there an angle whose cotangent is -1? If you don't like this, you can flip this to its reciprocal, which is tangent, which flips that over. It still keeps it -1. Cotangent is just x over y. So cotangent and tangent work the same way. So they're negative here and here. That means I have one angle that starts here and ends here, and I have another angle that starts here and ends here. So I label the sides 1, 1. There's my 45-degree angle. Whether I stay with cotangent or tangent. But after we find out that this angle is, this is 4 pi over 4, and we want all solutions. So instead of writing this twice with 7 pi over 4, we just said x is equal to 3 pi over 4 plus n pi. But now, once we found that, we had to deal with that 1/2. So we brought the 1/2 back there. Solve it as a regular angle first. And then bring the 1/2 back there. Like a lot of them we did were multiples. They were 2, 3, 4. So then we divided everybody by 2. So now you're going to do the opposite. You're going to multiply this guy by 2 so that I get a 1. You have to multiply this guy by 2. You have to multiply this term by 2. You have to multiply all the terms. This gives me 6 pi over 4, which reduces to 3 pi over 2. And n is any integer. Okay? Treat it like a regular angle first. Solve it for the regular angle, then deal with the half. I find kids do so much better with the multiples than the halves. It must be just harder to see. A multiple angle makes so much more sense. If I have 2 and I multiply it by 2, I get 4. So I think the multiples just make a lot more sense. Are we good? All right. Again, find all solutions. This is a nice one to factor. X squared minus x minus 2. Factor it. This is even nicer because we don't have an angle whose sine is 2. Sine only goes up to 1 and -1. So we reject that. And remember, the sines and cosines that are 1s and 0s were from your quadrants. So I draw my quadrants, or I can put this in my calculator. I could say, let me put this in mode, degrees, so I'll understand it. And I could say second sine, -1. Who has this? Oh, it's a -90. Now, let me find out where -90 is. -90 is here. But I have to define this between 0 and 4 pi. So could I call that -90? How would I name this angle? 3 pi over 2. It's its coterminal angle. 3 pi over 2. It's the same position. And then back around, we had the same thing like the last problem. 7 pi over 2. But if you get stuck, your calculator does the restricted one. Then we'll mark it down where it is and just rename it. Sine and tangent will give you negatives. Cosine won't. But sine and tangent will. Alright. This one took a lot of work. You had to get everybody to one side. So, get everybody to one side first, or replace it first, whichever one you wanted to do first, it doesn't matter. But I have 2 variables here. I have one in terms of sine and one in terms of cosine. And I can't, and if you moved everybody to one side first, maybe you saw it a little bit better. I realize now I've got 2 different variables here. Whether you do it first or last, it doesn't matter. But I gotta replace this. There's one identity, sine squared plus cosine squared equals 1. This one I have to remember. That's Pythagorean's identity. So I could solve in terms of sine squared. I can't replace a cosine x. That's the lowest it could go. I could replace my sine squared x with 1 minus cosine squared x. This is the guy I need to replace. When you do all this, and you get them to one side, just be careful. You want your, this is on all one side. Let's just do it this way in case you did it this way. You're on one side of the equal sign. A negative 2 and a positive 5 give you 3. Give you positive 3. So 2 cosine squared minus 7 cosine x plus 3. Now, still looks bad because a was not 1, but there's only one set of factors for 2 and one set of factors for 3. And what are the signs of both of these binomials going to have to be? Both going to have to be negative. Because I need to add to a negative, but I need to multiply to a positive. So all I have to do is figure out, where do I put the 3? Where do I put the 1? That's all I have to figure out. At most, 2 times it will take you to get this. If I put the 3 here by accident, this would give me negative 3 cosine. This will give me negative 2 cosine. Up, I only get negative 5. So I change those. I put the 3 here, I put the 1 here. And I get negative 6 and negative 1. Okay? I don't know why I put an X here. That was supposed to be 1. Okay, so now, from this point, how nice is this? This guy rejects. Cosine 1/2. Cosine is positive wherever x is positive, 1 and 3. X over r. This is a 60-degree angle. So I name this one and this one. If I'm doing all solutions, then this guy would be pi over 6 plus 2n pi. And this guy would be 5 pi over 6 plus 2n pi. Oops. 11 pi over 6. Whoops. Start again. 11 pi over 3 to 60 degree, sorry. And then 5 pi over 3. If I wanted all solutions. But since we just had to do this, keep your pattern going in this. 6 goes in here 3 times. So this is 3 pi over 3. This is 6 pi over 3. If I add 3 more, what is this one? From 6. 6 and 3 is what? 9. If I add 3 more, this is 12. So if I only have to go from 0 to 4 pi, I've got my pi over 3. I've got my 5 pi over 3. I come back around after 6. Oh, that's my 7 pi over 3. And right before 12, there's my 11 pi over 3. You can do it that way, or you can add your 2n pi to that. Either way, since you're only doing a couple more, just keep your pattern going. Some of you looking like me, like we never did this before ever. And the last one. Again, this is a half angle. Treat it like a regular angle. This one was a little trickier. I wouldn't give this to you on a test, but it was a good challenge for a homework problem. So I'm going to treat this like an X right here. I'm going to put this in green. This is just X right now. I come down here. I find, oh, tangent, who has a 1/3? I don't know this because this is a 1, this is a 3. That's not one, oh sorry, this is a 1. This is a 3. That's not one of my special triangles. So yeah, you're right, it's not. So find me this angle. So this angle works out to be 18 because in my calculator, I say, okay, what angle is this? And it says 18 point something or other. So I round it to 18, I want it in radians. And I convert this times pi over 180. So this goes in here 10 times. So it's approximately pi over 10. It was a nice challenge, not on a test, but it's nice to be challenged on a homework problem. So once I get that, then I'm going to deal with my 1/2. I'm going to multiply everybody by 2 because I want this to say 1x. When I multiply this by 2, 2 pi over 10 is the same as pi over 5. 2 times n pi, 2n pi. This guy I recognize. Oh, there's my 45-degree angle. Find my 45-degree angle because this is my plus n pi. Multiply everybody by 2. This we just had before. And then 0 to 4. You can go 0 to 4. Can everybody take this right here and add 2n pi to this? If I have an angle, 3 pi over 2, and I have to add 2n pi, it's not a fraction. How do I make this a fraction? Put it over 1. So my fractions say my denominator has to be the same, right? For me to add? So what's my common denominator? 2. So 1 times 2 gives me 2. So 2 times 2 gives me 4n pi. So each time I'm technically adding 4 pi. So I start with 3 pi over 2. I add 4, I get 7 pi over 2. I add 4, I get 11 pi over 2. But there's got to be a place I'm going to stop. So I could have just made this one be in terms of 2, and I would stop at 8 pi over 2. I didn't need this guy. Okay? Or, say, okay, if there was 1 angle, 2 angles, and 2 pi, and I used half of those, I would use 1 angle and 2 pi. How many angles would I need in 4 pi then? 2. 1, 2. This does make sense if you make it make sense.